Here's another homework problem from homework number 10. Seems to give, the first part usually goes pretty well, but the second part gives students a little bit of trouble, so we'll go through this one together. A tire company produced a batch of 5,600 tires that includes exactly 230 that are defective. So we are told we have 230 defective tires. So in terms of the probability of having a defective tire is going to be the 230, the number of ways we can get it defective, or out of the total 5,600 tires. Okay. However, in part A here, we are asked, what is the probability that 4 of the tires that are randomly selected, that they are all good, that they are all good, all 4 of them are good. So you're going in to get a set of new tires for your car. What's the probability they're all good? So we actually want to know the probability of 4 good tires. Okay, well that's like 4 events all happening, ands, so we need to multiply the probability the first one's good times the probability that the second one is good times the probability that the third one is good times the probability that the fourth one is good. All right, but we don't actually know this probability of it being good. What we've got up here is the probability of it being defective. Well, we know that the sum of the probability of an event plus the probability of its complement is always 1. Well, let's think about it. The probability of a not defective tire, the complement of a defective tire, is going to be the same thing as it being good. So being good is the complement of being defective. So that is going to be your remaining number. So we can take 5,600 and subtract off that 230, and that is going to equal the 5,370 remaining tires will be good. So the probability of choosing a good tire will be that 5,370 over the total 5,600. So that's actually the probability we need right here, the probability of a good tire. Okay, so we're going to start plugging that in. All right, the probability that the first tire is good is going to be that big number, 5,370 divided by 5,600 times. Now, what's the probability the second one is good? Now, we have no replacement here. We're buying 4 tires for our car. So there's one less tire there now that's good. It's going to be 5,369 tires that are left that are good out of a total possible 5,599 tires remaining. And we're just going to continue on this process. So the third tire, there will be 5,368 to choose from out of a possible 5,598 total number of tires left. And lastly, by the fourth time, there will be 5,367 good tires left out of a total possible 5,597 tires. All right, so you can take a minute now and plug that into your calculator. Use your fraction button and go ahead and compute that. Hopefully you'll get on your calculator 0.846. If not, go back and check that you punch those numbers in carefully. That's a lot of them. So in other words, there are roughly an 85% chance if you buy 4 new tires for your car that all 4 of them will be good. None of them will be defective and you won't have to come back and return them. All right, let's take a look now at letter B. Letter B says if 100 tires are randomly selected for shipment to an outlet, what is the probability that they're all good? So now we got to find the probability of 100 good tires. Now, if we use this method up above, that could take us all day. So I'm really not up for that. However, we have a rule that says if your sample size is no more than 5% of the population, then we can treat the events as independent. So let's see if that meets the criteria here. What is 5% of our population, which is 5,600? Again, you can do that on your calculator, but that's going to equal 280. So that's our cutoff point. And our sample size over here, our 100 good tires, is less than that. So we can use, we can treat the events as independent, which means we don't have to do all this dependent work. Each probability, whether it's the first or the last, will be this same probability of the first one being good. So rather than writing this 100 times, because that's what we'd have to do, we can simply write it as the probability of one good tire to the power of 100. It times itself 100 times. It's the same thing. All right, so in this case, the probability of one good tire is 5,370 over a possible 5,600. And I'm going to put that to a power of 100. Normally we don't write that caret sign. I'm just doing that for you so that you know how to plug it into your calculators. And if you do that on your calculator, you should get a value of 0.015. So roughly 1.5% chance that all 100 tires will be good. All 100 tires good. That's a pretty small percentage. So I think my thinking would be that this company, this outlet plan, they should have a plan to deal with the defective tires, because the chances that all of them are good, and 100 tires really aren't that many. That's only 25 cars, so chances are that some of those tires will be defective, so they should have a plan. All right, try it yourselves.